Hello friends, in this session we'll discuss a very important question on view serializability, and it has 5 transactions and 5 data items in its schedule mentioned in the question. So the question goes like this, that check whether the schedule given is view serializable or not. So we need to check if the schedule given is view serializable or not. And over here what we have in the schedule is we have some operations written. So what is the first step? The first step is to populate that table which has 3 operations on its left hand side, which is initial read, update and final update, and all the data items written mentioned as the columns over here. So we'll just populate this. Now when we start for data item A, what we notice over here is that what we check for is initial read. So whenever we check for initial read, what we check for is the read operations before any write operation. So we get to know there is one read operation which is read 1A, and then we check for any updation or read operation. So there is no updation, but there is a read operation over here. So is there any updation? Let me check. So there is no updation as such, but there is no updation operation, so therefore we just have the reads over here. So we have T1 and T5 performing the reads, right? So there is no write operation, so there is no final update operation as well. So we just put cross over here. Now since there is no write operation, there occurs no conflict because of this, and we don't get any order constraints from here. So the only thing we get to know is T1 and T5 perform initial reads. Since there is no transaction updating it, no case will occur in which these initial reads will be violated, and there will be no read write sequences as well. So we also do not need to check them for that case. Fine. So we move on to the next data item, which is B. In case of B over here, what do we do is we check for initial reads, and when we check for initial reads, we get an updation operation over here. So there is no initial read essentially for B, because any read after this won't be counted as initial read because it now reads the updated or modified value of B. So therefore we put a cross over here and we check for the updation operations of B now. So T1 updates it clearly, then T3 updates it, and then there is no other transaction updating it. So we have T1 and T3 over here, and the final update will be counted as for T3 because T3 was the last to update it, right? Next we then move to the data item C. When we check for initial read of C, we get a write operation on C over here. So any read after this will not be counted as initial read, so we put a cross over here, and we have this updation on C with T2 transaction, and there is no other transaction updating it, so therefore T2 only becomes the final update operation for data item C. So next we move on to D data item. We get an initial read over here, so T3 is reading it initially, and then there is no update operation on it, so we put a cross over here and a cross as well over here. Then we check for data item E. When we check for data item E, we check that there is no initial read because there is an updation over here, so we put a cross in the cell of initial read, and then there is an updation by T4 transaction, and there is no other transaction updating it, so this transaction T4 only becomes the final update operation. So T4 is updating it, and T4 is the only one updating it finally. So that's all for the table of this. Now we analyze the entries into this table. So when we analyze the entries, when we analyze the ones corresponding to data item A, we get to know that there is no write pair and hence no conflict as we just discussed. Then we discuss the data item B over here. For data item B, we get to know that T1 should always come before T3. That is only the constraint over here because there was not initial read, so we just have a constraint corresponding to update and final update. Similarly, when we analyzed data item C, there is no initial read and only one transaction updating it and finally updating it, so there is no order constraint possible over here as well. Similarly is the case for D and E. So finally, from this entire table, we just have one constraint, which is T1 and then T3. That is, T3 will only come after T1. Now, nowhere does it says that T3 will come at the end of all the transactions, because there is no other transaction in this picture over here. So that means T3 updates it finally, and it only had a constraint with T1. So it says that T3 will only come after T1. Now we analyze the read-write orders. So over here is the main question where you can say there is a need of analyzing the read-write orders. And why is it so? Because we just have two transactions available with us. We don't know any other thing about the other transactions. So which are the data items which we need to check now? So the data items that we need to check is B, C, D. B, C and E. Now why am I saying that we can just ignore the data items A and D? Because there is no write pair over here. Since there is no write pair over here, there will be no read write pair, right? So we can only check for B, C and E. So I'll just overrule the processes operations on A and D for now, and we'll just concentrate upon the operations on the data items B, C and E. So when we check the read-write pairs for data items B, C and E, I've just jotted down the read-write pair operations. So when we check for B, we get to know these are the operations. W1B, R2B is a pair which occurs. So from this pair, if I see, I'll say that T1 occurs before T2, because if this order has to remain the same, then this thing has to hold. Similarly, I compute the orders for all the possible pairs, and I also write the additional constraint that we got from the table above, which is T1 and then T3. Now, considering these orders, I'll be forming the final order for this question solution. Fine. So in the next sheet, what I've done is I've just written these orders, the ones which I found from here, and there are 6 orders. So analyzing these 6 orders, now we'll have to get concluded to one of the final order for our final possible schedule. So this basically shows me, when I tried out finding the solution for this question, I got to know there were multiple possible schedules possible, and so from the perspective, from an exam perspective point of view, I would say that it will be better that you take these constraints and you just try out these constraints on the options given to you, so that you just get to know the answer in a quick manner rather than just computing it by yourself. So for now, since I don't have the options, I'll be just forming the possible solutions. So let's say I start with T1, and from T1 I say that there is T2 should follow T1, and I just write T1 and T2 directly. Then I'll check which is the transaction which should come after T2. So I have this constraint over here, T2, T3. So I wrote T2, T3, and then we have T4, T5 over here, and also T1, T4 over here. That means T4 should come after T1. So next transaction which I wrote over here was T4, and since T5 should follow T4, so T5 comes over here. So now again I'm repeating, this is one of the possible solutions. This is not the only possible solutions. We'll be discussing 4 such solutions over here. So next what I do is I just in order to make you all clarify the concept, in order to you understand the concept, what I've done is I've just labeled these edges in the form of the constraints that I've considered while writing this order. So for example, T1 and then T2, so that means I've just labeled this arrow as 1, then this arrow as 3, and so on. So this is the graph which represents how I have computed this possible order. So one of the possible orders over here is T1, T2, T3, T4, T5. Then another possible order that was coming out to be was T1, T2, T4, T5, T3. Now how is that so? Because it is very clearly said that T4 that T4 should come after T1, and we also have that T2 and then T3. That means T3 cannot come before T2. So what I did was I just swapped this T3 at the end. I just moved this T3 at the end. So another order that came was this, and then I checked whether all the constraints are being satisfied over here. So it did became true. All the constraints were getting satisfied. Another order which is being formed is T1, T4, T2, T3, T1, T4, T2, T5, T3. You can again check all the constraints in correspondence to this, and the final another order which I am getting is T1, T4, T2, T3 and T5. So these were the 4 orders that we got from this question. Again, I would say that you might get some other order as well, but the only thing that you need to check that if that answer is correct or not is to check if all these 6 constraints get satisfied with that schedule or not. So that's all for the question, for this particular question, and I would really say this was a very important question and one of the most difficult questions that an examiner can probably ask you from this topic. So all the very best for your exam, and keep subscribed for more good work coming up. Thank you.